So there is a procedure for finding a relative max min for a function with two variables. And this is called the d-test. In order to apply the d-test, I need some preps. First prep is to find fx and find fy. Okay, so again, let me refresh your memory on what fx means. This is the partial derivative of f of xy with respect to x, meaning y is fixed. So this is the partial derivative of this function with respect to x, considering that y is fixed, or if you want to say constant, one or the other. The same thing with fy. It's the partial derivative of this function with respect to y this time, when x is fixed or x is constant. Okay, so that's our first prep. So fx. When I differentiate with respect to x, this term does not have x in it, so it will be 0 when I differentiate it. When I differentiate this with respect to x, I get 3x squared. This is gone. When I differentiate this with respect to x, I get negative 3y. Is this okay, everyone?
Yeah.
Let me know if you have questions. Don't let me move on. Yeah, somebody else wanted to say something. Sorry. Oh, there is a chat. For me, is it for me? Maybe we try some random ones. What does that mean?
Like the beginning of class, we were talking about trying word problems.
Oh, yeah, sure. Okay, so moving on to fy. Fy means
I have a question.
Yes?
So if you're keeping y constant, then wouldn't the y cubed also have to go on there? You're not really touching it.
So y is fixed. So this piece is constant. Is a number. When I differentiate a number.
Okay. So it becomes 0?
Yes.
Okay.
That's why I covered it. So now, when I differentiate with respect to y, I have to cover x cubed. This is a number. So then I will have 3y squared. And I'm differentiating with respect to y, so this is minus 3x. So for the d-test, which will tell us whether this function have a max or a min or both or none of the above, our first step is to determine fx and fy. We did. In step 2, we have to set these two equal to 0. We create a system in which we have 3x squared minus 3y is set equal to 0, which means fx is 0 and fy is 0. And remember, this is exactly what we did for finding critical numbers before, right? We had f prime of x equals 0 to find the critical number, or f prime of x being undefined. So this is pretty similar. So this is not relevant here, but this is the idea that we used before for functions of one variable, one independent variable. So when I set these two equal to each other, first of all, I will divide both sides by 3 in both cases. The top one is x squared equals y, because I'm moving to the other side. And this one is y squared equals x. Look how interesting. Okay, so now we have to try to solve this. One option would be I replace y by x squared here. Or you can say y, replace x here by y squared. It doesn't matter. It doesn't matter. It's going to be anyway substitution. So let's say I replace y by x squared. Y is the same with x squared, so I plug it in here. So this becomes x squared squared equals x. Because y equals x squared, so I replaced y by x squared and I have squared. So this is basically x to the fourth equals x. Okay, so I move everything to one side and factor out x, and I have x cubed minus 1 equals 0. So when I move x to the other side, I see that x is a common factor. X times x cubed is x to the fourth, and x times -1 would be negative x because this goes to the other side. Let me write it here so you can see it. And then I factor out x, and I have x cubed minus 1. This equation, although it has 4 solutions, only 2 are real numbers. And they would be, and of course, you have the right, okay, let's do that. You have the right in this class, because if you don't remember anything about factoring, there is no way for me to teach you. It's too late right now. So you are allowed to use this, and you will see we will have degree 4. Careful what you plug in. Degree 4. And then we have the first coefficient, remember, is 1. The next coefficient is 0. The next coefficient is 0. The next coefficient is 1. And the next coefficient is 0. Be very careful how you plug them in. So this is 1, 0, 0, 1, 0. So when you click enter, we will get x equals 0 and x equals 1. And the other two, because degree 4 solutions, the other two will be imaginary. They will have I in them. Here it is. So as we expected, x equals negative. Why negative 1? Ah. How do I go back here? Okay, so as expected, 1 and 0. Good. So the other two are imaginary, 1 and 0. How did I know that? Because when we factor this, we know that, so I'm on page 3. So from here, I have x equals 0 and x equals 1, and 2 others are imaginary. So if you want, you don't have to write anything at this point. So for each x value now, I have to find the corresponding y value. That's fine. So when x is 0, y is 0. So I found 1 point, 0, 0. When x is 1, y is 1. So I found another point, 1, 1. Do I know what they are? No, not yet. So let's refresh, go back. Number 1, we determined the 2 partial derivatives. Number 2, we set them equal to each other to 0 as we did in the past with a function of 1 variable. We solved the system. We got 2 ordered pairs. Now in step 3, I have to find fxx, fyy, and I have to find fxy. I don't have to find fyx because I know they will be the same. So we differentiated with respect to x the first time. Now I want to differentiate this again with respect to x. So I get 6x. We differentiated with respect to y the first time. Now I want to differentiate again with respect to y. 6y. Now I differentiated with respect to x the first time, and now I want to differentiate with respect to y. -3. If you want to check, that's fine. We differentiate this with respect to y, we did, and now with respect to x, -3. Final step before we make draw the conclusion. Number 4. Determine d. And here's the formula for d. fxx at these points, I'm going to call them a comma b because that's the formula, so to remember it. Fyy, first at the first one and not at the same time, right? First I check the first point if it's a max, min, or nothing. Then I check the second point. So a comma b and minus fx y at a comma b, but this has to be squared. For the first point, I determine d. For the second point, I determine d. So let's do that, and then I'll show you the conclusion. So d for 0, 0. fxx at 0, 0 is 0. Because when I plug in 0, I get 0 times. fyy at 0, 0 is also 0. Minus. fxx, I cannot plug in anything. It's fixed. It's -3. So -3 squared. So -3 squared is 9 with minus in front. This is -9. And the d-test says if d is a number less than 0, no max min at 0, 0. Now for d11, fxx at 1, 1 is 6. fyy at 1, 1 is also 6. This cannot change, so this is still 9. 36 minus 9 is a positive number. Every time d is a positive number, we look at fxx. This is fxx. fxx is 6, which is also a positive number. Therefore, 1, 1 is a relative min. How do I determine it? I find f of 1, 1. This is the relative min. This is where the relative min is located. At 1, 1, x is 1, y is 1, but now I want to find the relative minimum value of the function. So I go back to the function. Where is it? Here it is. And I plug in 1, 1. 1 plus 1 and minus 3. So this is -1. So the relative minimum is found at the point when x and y are 1 and 1. The actual relative minimum is -1. So now let me give you the entire test so you have it in your notes, and then we can choose another problem. That's all you need to do. So we know what d is. So here are the options for d. Let me see, how am I with time here? Oh, good, good. What is going on here? That's not good. Okay. So if d is a positive number, there are two options. For fxx to be less than 0, and this is a relative max. For fxx to be greater than 0, like we just had, and this is a relative min. If d is less than 0, no max min. If d equals 0, the test is not applicable. Test is not applicable. So d is a number. If it's positive and fxx is negative, relative max. If d is positive and fxx positive, relative min, like we just had. If d is less than 0, like we just had, no max min. If it happens that d equals 0, we cannot conclude anything. Okay, so now let's choose other problems to look at. And then I would like to, what am I doing here? That's not it. What am I doing here? That's not it. I want 5, what is it? 570, what? 576. 576, yes. And I'd like us to look at a word problem, since you already asked about that. So let's look at a word problem. Maximizing profit. So let's start, since you already had a concern about word problems. I think we should start with that. It's a very good point. Thank you. Good. So maximizing profit. The moment they say maximizing profit, I know I have to look at the first derivative. If the function has one variable, If the function has two variables, then I have to look at the d-test, and that clarifies everything. So there is nothing else, right? When it says maximum, I know I have to find the derivative and the sign of the derivative if the function has one variable. But since the function has two variables, then I know I'm looking at the d-test. And that solves all the questions that you may have on word problems from this section, right? So let's copy this. So this is 21, p of a comma n, negative 5a squared minus 3n squared plus 48a minus 4n plus 2an plus 290. A is the amount spent on advertising in millions. So A, millions. Fine. N is the number of items sold. Items. Okay. In thousands. Good. I have that. Find the max value of P and the values of A and N, at which it occurs. So this is very clear. I see a function of two variables. I'm thinking of the d-test right away. There is nothing else I can think of. Is this okay? Is this clear so far? Is that a yes or a no?
Yes.
Okay, perfect. So for the d-test, first I have to find PA and I have to find PN. This should be the partial derivative of P with respect to A. This should be the partial derivative of P with respect to N. But this is a cumbersome notation. We are reducing it to PA and PN. Okay, so when I differentiate this with respect to A, this has A, this has A, this has A. Everything else is gone. So this with respect to A, negative 10A. This with respect to A, 48. This with respect to A plus 2N. Now with respect to N, this, and this. Everything else is gone. I differentiate this with respect to N. I differentiate this with respect to N, and I differentiate this with respect to N. So this is my step 1. In my step 2, I have to set these two equal to 0. Create a system in which I have negative 10a plus 2n equals negative 48, negative 6n. I want to put them in the exact same order, because I'm simplifying everything here, getting it ready to solve it. So 2a minus 6n equals positive 4. And now I will decide which variable to eliminate. If you want to eliminate a, then you have to multiply both sides here by 5. If you want to eliminate n, then you have to multiply both sides here by 3. It doesn't matter which one we eliminate, but let's choose one. Which